This content is brought to you by Mazundar Academy.
Hello everyone, welcome to Mazundar Academy. This lecture series is made just to help students, and there is no intention for doing any commercial activities. The content made for class 9 advanced mathematics under Central Board of Secondary Education CBSE curriculum. So the first topic, that is chapter 1. Chapter 1 is set. So at the beginning, let us introduce set. Actually, this set we are using in our daily life in many ways, in many times, but we do not know that this is a set. So we are using it, but as we are not aware that that is a set, or some of us may aware of it, that so we will see explicitly about the set today. Basically, set comes from any collection. Say for example, collections are denoted by this curly braces. For example, if you are collecting some names, say Akash, say Ahmad, Jyoti, okay, etc. Suppose 3 names I have taken. This is a collection. Another collection, say I have taken letters A, B, P, Q. Okay, this is another collection. I have taken some other letters, say numbers, for example 1, 2, 3, 4, another collection. Okay. Now some collection will represent set, some will not represent set. Some of the collection we will say yes, this is a set, and some of the collections we will say it is not a set. So how to identify which one is a set and which one is not a set? See, any collection, if it does not vary from person to person or time to time, then that collection will represent a set. And if the collection may vary, its elements may change time to time or person to person, so that collection will not represent a set. For example, if I take a collection, say collection of vowels. So collection of vowels, what will be the collection? A, E, I, O, U. Now if you write the collection of vowels, if I write, if someone X, Y, Z, whoever write, this collection will not change. These 5 letters will always come. So these collections, the collection whose elements are not going to change, if you make the collection multiple times or multiple people, so those collection will represent a set. So this is a set. This will represent a set. Another collection, say a collection of favorite subjects. Now say for example a collection of 3 favorite subjects, okay, of 3 favorite subjects. So in that case, if I write, it can be maths, science and English. But these 3 subjects favorite to me. If somebody else write, then maybe he doesn't like math. Someone else may choose science, then English, history. Someone else may choose English, Hindi, maths. So it may change from person to person. So this collection of 3 favorite subject, this collection does not represent a set, not a set. So what we understand? Any collection whose elements are fixed, it will not change. Those collection will represent a set. And if any collection whose elements will change or it may change or which is not properly defined, those collections will not represent a set. There are many examples. Suppose group of best student, collection of best students, collection of favorite teachers, collection of good students, collection of meritorious students, like this. The things which are not well defined will not represent a set, and anything that is well defined or it will not change its element, that will represent a set. Another example if I give, say a collection of 5 positive integers less than 10. So collection of 5 positive integers less than 10. So these integers can be 1 2 3 4 5, or it can be 2 3 4 5 6, or it can be 3 4 5 6 7, like this. Okay, since it is not fixed, so this collection will not represent a set, At the same time, if I change my domain, say collection of 5 positive integer less than 6, collection of 5 positive integers less than 6, then in this case you see only the possibility is 1 2 3 4 5, and there is no other options. Anybody, if you think of this collection, they will write only 1 2 3 4 5. So in that case, this collection will represent a set. So this will be a set. I hope now you can understand that which collection will represent a set and which is not. Okay, let us move forward and give the definition of a set, formal definition. So you can see here, a set is a well-defined collection of objects. Well-defined collections. The object must be properly defined, and the objects in a set are called elements or members of the set. Already we have seen how the members are written, like here mathematics, science, English, A, E, I, O, U, these are called members. 1, 2, 3, 4, these are members. A, B, P, Q are members. Okay. Now we will move to the representation of sets. Now the representation of sets are represented in two forms. One is roster form, okay, roster form, and another one is set builder form. So both the forms we need to understand, then only we will get to know how it works. So the roster form is something if you write in brackets, directly the elements if you write within the brackets. For example, if you have written one more point, remember here, a set is denoted by capital letters in general. Okay, in general a set is denoted by capital letters and the elements by small letters. In general, so for example, capital A equal to say A, E, I, O, U, like that. So the name, especially here, the capital letters are used to denote the set. So now roster form, already I can give this example, say capital A equal to 1, 2, 3, 4, 5. So this is the set representation in terms of roster form, or it is also called list method. Okay, list method, because all the elements are listed within the curly braces. That's why it is called list method or roster form. There is a symbol, let me tell you this symbol here itself. This symbol might be, some of you know, this is called belongs to. This symbol, what is the name of this? Belongs to. Belongs to. Okay, belongs to. What it means? It means, say for example, 2 is inside this set A, so I can write 2 belongs to A. Belongs to means whether it is present inside or not. So whether 2 is present inside A, yes, 2 is present inside, so I can write 2 belongs to A. And the opposite one is does not belongs to. This one does not belongs to. Does not belongs to. So for example, 7 does not belongs to A. That means 7 is not available inside the set A. So I can write 7 does not belongs to A. So I hope belongs to and does not belongs to clear. If something is inside available, then we write belongs to. If not available, we write does not belongs to. Okay, so second is set builder form. set builder form means what? Your set will be written in terms of some common property. In terms of some property or description will be given about the set without explicit elements of the set. Elements of the set will not be given. The description of the set will be given. For example, if I write, say, B is a set, all those X such that X is a vowel in English alphabet. If I write like this, all those X, collection of all those element X such that X is a vowel in English alphabet. Now if you find out the elements of this set, then what will happen? What will be this? It will be A, E, I, O, U. Okay, so writing like this, actual elements and writing the elements as a description, both are two different notations but representing the same set. If I write like this, then it will be a list form, that is roster notation. And if I write like this, then it will be set builder form. Both will represent the same set, but both of them are in two different notations. So your question may be in your exercise or in your exam, one of the form will be given to you and we will ask you to write the other form. For example, set builder form given, you have to write its roster notation, or say roster notation given, you have to write its set builder form, vice versa. Okay, we will see it in our exercise questions. Let us finish the theoretical concept first. Our next concept is finite and infinite set. So you can see in the name itself, finite means what? The element will be fixed and finite. It's not like up to infinite, means continuously going, not like this. So finite. And infinite means there is no end. There is no end of the elements. So mostly I am not going to definitions and all. Mostly I will give you the example. For example, say if I write a set, say capital A equal to all those X such that X is an integer, X is an integer and -2 less than or equal to X less than 2. So this is a finite set. How? If I work out this set, what are the elements will come for me? The elements will be, its actual element will be what? It should be integer between -2 to 2. -2 inclusive, 2 not inclusive. So it will be -2, -1, 0, 1 only. So this is a finite set. At the same time, if I choose another example, so this is a finite set. Okay, this is a finite set. Finite set. Another example, if I choose say B equal to all those X such that x is an integer and x greater than 0. Now imagine if you work out the elements of this set, x greater than 0 and it should be integer. So it will start with 1, then 2, then 3, then 4, then 5, and as big as you can, you choose. There will be no end of this. There will be no end of this, of the element of this sets. Therefore, this set is an infinite set. This is an infinite set. There are many examples. The collection of all prime numbers, okay, the collection of even numbers, collection of odd numbers. These all are infinite sets. And if the elements are fixed, elements have finite elements, if the set have finite number of elements, then that set is called finite set. I hope it is clear to you. So there are, say for example, set of events, okay, the collection of even numbers, the collection of even numbers, or even integers, you can say even integers, then odd integers, then say prime numbers, okay, prime numbers. These all are infinite sets. Even numbers means what? If you remember, what are the even integers? If I say integer, then 0, 2, 4, 6, 8, like this, up to infinity. What are the odd integers? It will be 1, 3, 5, 7, 9, 11, this all, okay. And if I talk about the prime numbers, then it will be what? 2, 3, 5, 7, then 11, 13, like this. These are prime numbers. These all are infinite sets. These all are infinite sets, okay, infinite sets. So this is about your finite and infinite sets. Next we will see what is empty set or null set. So empty or null set means what? A set which does not have any elements. A set that does not have any elements at all. If I give an example, then you will understand. Say, suppose capital A is a set, all those x such that x is an integer and 1 less than x less than 2. So basically, how many elements, how many integer elements between 1 and 2? Nothing. Because if you see the integer line, you can see here the set of integers 0, 1, 2, minus 1, and this is up to from minus infinity to plus infinity, okay. So in between 1 and 2 there is no other integer. So this set A is empty set. It is blank set, okay. There is nothing inside this set. So this kind of set is called an empty set. Now empty set is denoted by phi. Okay, empty set, it is denoted by either phi or this blank. Okay, blank curly braces. So anyone you can use as a notation of empty set. Next, we have equality of sets. Say two sets A and B, two sets, we will say them equal if both the sets have the same elements. If both A and B have the same element. Same elements. For example, say A equal to 1, 2, 3 and B equal to 3, 1, 2. So here you can see 1 inside A, 1 inside B, 2 inside A, 2 inside B, 3 inside A, 3 inside B, and there is no more elements available inside any one of them. Therefore, A and B are equal. And if you have any extra element in one of the set which is not available in another set, then we say they are not equal. Say for example, say you have another set C which is 1, 2, 4. So in that case you can say A is not equal to C, or you can say B is not equal to C, because A and C, if we compare 1, 1, 2, 2, but 3 and 4, they are not same in both the sets A and C. Therefore, A is not equal to C. Similarly, B and C also you can see 1 and 2, they are same in both the sets, but 4 and 3, they are different. Therefore, they are not equal. Okay. So with this, we have come to an end of the theoretical discussion, and next we will move to solve the exercises. Thank you very much. See you in the next lecture.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.